Bismillahirrahmanirrahim. This is Pakistan International School Taif. Assalamu alaikum. Dear students, this is a continuation of previous lecture. Now we start the lecture number 8 for the second year class, grade 12. This is grade 12. And we already started chapter number 13 and we are talking about S and P block elements and group 2 elements we started studying. Group 2 elements: radium, magnesium, calcium, strontium, barium and radium. Now dear students, we today explain the trends in thermal stability of carbonate and nitrates of group 2 elements. Means when we are heat, what happens? Thermal stability of the group 2 elements of carbonates and nitrates. So, dear students, you have to open your books. You should have books. If you see the page number 34 and 35, this topic is given: the effect of heat on group 2 elements of carbonates. This is the carbonates. And for matter, general carbonate, metal oxide and carbon dioxide. This is the heat. I have written the one example of magnesium carbonate, 440 degrees Celsius. It decomposes to give a magnesium oxide and carbon dioxide gas. Now, if you see the book, the stability of the carbonates of these matters increases as move from top to bottom. Stability of the carbonates of alkaline earth metals increases as we go down the group. So if you are going to decompose magnesium carbonate, so it needs 540 degrees Celsius to give magnesium oxide and carbon dioxide gas. So after the magnesium, then there is a calcium carbonate. This calcium carbonate needs calcium carbonate. So it needs about 900 degrees centigrade to give a calcium oxide and carbon dioxide gas. So this temperature is going to be unit more. So calcium carbonate upon heating more stable than the magnesium carbonate. So this stability increases as we go down the group. If you see your book, magnesium carbonate decomposes at 540 degrees centigrade, already I have written. Calcium carbonate needs 900 degrees centigrade, already I have written. Strontium needs 1290 degrees centigrade. And barium carbonate needs 1360 degrees Celsius. So from these chemical equations, decomposition of carbonates of alkaline earth metals, we infer that we get result that as we go down the group, the stability of the group 2 elements is going to be increase. So on the top of 36 page is written that stability of carbonates of these metals increases on moving down the group. So beryllium carbonate, if you write beryllium carbonate, it's highly unstable. Means round about 25 degrees Celsius it is going to be decomposed. At 25 degrees Celsius it is going to be decomposed. Now reason is given in the book. Page number 34 and 35 already I told you. The ease of decomposition of the carbonates can be related to the size of metal ion. Size of metal ion. Already I told you in the previous lectures that in the periodic table you can see the different properties: atomic size, ionization energy, electron affinity, electronegativity, melting point, boiling point, reactivity. So all they are depend with the metallic behavior, non-metallic, basic nature, acidic nature. All these are interrelated. So dear students, as I go down the group, the size of the ions of group 2 elements will be increased. Beryllium ion has a smallest size. First element of group 2 element. Radium, then magnesium, then calcium, then strontium, then barium and radium. So the reason is given here. The ease of decomposition of the carbonates can be related to the size of metal ion. Smaller the positive ion, greater the lattice energy of resulting oxides, hence higher the stability of the product and easier the decomposition of original carbonates. So this is easier. Beryllium carbonate easy to decompose, 25 degrees centigrade, and this is going to be more stable as I am going to go down the group towards the strontium and barium. This is the reason you can see from the book. So second is stability of nitrates. Stability of nitrates. So metal nitrate decompose to give metal oxide, nitrogen dioxide and oxygen gas. Nitrogen dioxide and oxygen gas there. So this is going to be, this is a Dunham reaction. So if you see your book, this topic, all the nitrates in the group undergo thermal decomposition to give the metal oxides. Already I told you, nitrogen dioxide and oxygen gas. So it is written, as we go down the group, the nitrates also have to be heated more strongly before they will decompose. The nitrates also become more stable to heat as we go down the group. Same trend for the nitrates it is. So as we go down the group, alkaline earth nitrates, stability of nitrate is going to be increased as you see the topic. So magnesium nitrate, if we heat strongly, we will get a magnesium oxide, nitrogen dioxide and oxygen gas. Same. Barium nitrate to give a barium oxide, nitrogen dioxide gas and oxygen gas. So, dear students, as we done previous, that stability of nitrates of group 2 elements increases down the group. So it means that magnesium nitrate is less stable than calcium nitrate. Calcium nitrate is less stable than strontium nitrate. So nitrates are white solid and oxides produced, and also with the white solid, brown nitrogen dioxide gas is going to be involved. Magnesium and calcium nitrates normally have a water of crystallization. Water of crystallization crystallization. You done it in the grade 11. Also maybe in the grade 9 somehow. Grade 11. Physically, with the compound, if water molecules are going to be added, just like we say, water of crystallization, like this one. Yes. Physically, this water, not chemically, physically, X number of water molecules, after crystallization, when you are going to crystallize this salt, some water molecules are going to attach with the crystals of magnesium nitrate. This is called hydration or water of crystallization. So according to this topic, the magnesium and calcium nitrates normally have water of crystallization, and solid may dissolve on its own water of crystallization to make a colorless solution before it starts to decompose. There is one thing I told you, this is for your remembrance. I told you this is given down also. First element of its own group does not resemblance with same group. It resembles with the next element, second element of other group. So I told you lithium shows a resemblance with the magnesium of group 2 element. So dear students, if I am going to decompose the lithium nitrate, which is present in group 1 element, so this will give a lithium oxide, nitrogen dioxide and oxygen gas. So, same magnesium nitrate, magnesium oxide, nitrogen dioxide, oxygen gas. Lithium nitrate, lithium oxide, nitrogen dioxide, oxygen gas. Same. But if you are going to decompose nitrate of second element of group 1, lithium and sodium belongs to same group. So their property should be similar with the own group. But lithium resembles the magnesium of group 2, not its own. That is why if you are going to heat sodium nitrate, same group, so it does not form the oxide, but it forms sodium nitrite and oxygen gas. Sodium nitrite and oxygen gas is going to be formed. So this is a difference. This is a difference between the chemical behavior of the elements which are present in the same group. Same as, next topic we will discuss, same. This beryllium belongs to group number 2, also does not resemble with its own group. And the main reason is every first element of the group has a smaller size. Due to smaller size, it does not resemble. So we have here a new topic that how beryllium differ from its own group. We'll discuss. So this is the main reason. Lithium has a very smallest size. Beryllium has a very smallest size. That's why these elements have a main difference with their own elements, either chemically or physically. So, dear students, this is the behavior of nitrate of group 2 elements, and stability of nitrate of group 2 element increases as we go down the group. So, you should know this reason also. Lithium nitrate and sodium nitrate belongs to same group, but their chemical properties, decomposition of nitrate products are going to be different. And the reason I told you that lithium has a smaller size as compared to sodium, so it belongs to it, gives a property like group 2 elements. So these are the behavior of carbonates and nitrates of group 2 elements. Now students, there is I told you how beryllium differs from other member of its own group. Beryllium differ with own group of elements. It shows not resemblance with its own group. So here I told you the reason is given. Beryllium is the first element of group 2 elements of alkaline earth metals, and written here, due to the very small size. When the element have a smaller size, it means that it's more electronegative. Beryllium is a more electronegative than magnesium, calcium, strontium. Electronegativity decreases as we go down the group. Written in the book, due to small atomic size and comparatively high electronegativity. So due to these two reasons, beryllium shows a different behavior with its own group. One by one. Hardness. Beryllium is much more harder than that of the other element of the group. Very hard. Hardest of all elements of the group. Melting point and boiling point, already you've done this. A boiling point of beryllium is the highest among all elements. Because of the beryllium has smaller size and more electronegative nature, so it should form covalent compounds. So beryllium oxide is an amphoteric. It shows covalent behavior. It shows amphoteric nature. So it forms covalent compounds, more electronegative. So when it reacts with other elements of the electronegative difference is not much large, and bond is going to be covalent. Reaction with water. Reaction with water. We done the same. I told you there are many repetitions. Reactivity of the alkali metals and alkaline earth metals increase down the road. We discussed before. It means that among the all elements, group 2, beryllium will be least reactive. So written here, it does not react with water. Beryllium does not react with water. And we done the chemical reaction of magnesium with water. Magnesium with water. So magnesium reacts slowly with water to give a magnesium oxide and hydrogen gas, steam. I told you there are two chemical reactions of magnesium. We already discussed finally divided magnesium pure if you put on water, chemical reaction is very slow and to form magnesium hydroxide and hydrogen. But if you are going to pass steam on the magnesium, it form magnesium oxide and hydrogen gas. Reaction with hydrogen we call hydrides. Reactions we called hydrides. Binary compounds of hydrogen are called hydrides. Binary compounds of hydrogen are called hydrides, just like lithium hydride, magnesium hydride. These are called binary compounds. These are ionic compounds, and ionic nature, going to be increased as we go down the group because of electropositive character and metallic character is going to be increased. So metal can lose electron very easy. So lithium is metal, hydrogen is non-metal, positive 1, negative 1 charge. Magnesium is metal, hydrogen is non-metal, positive 2 and negative 1 charge. So these are called hydrides. Beryllium does not react with hydrogen directly to form hydrides. No reaction. Does not. First element, this beryllium does not react directly with the hydrogen to form hydride. Less reactive, very less. Its hydride, however, has been prepared indirectly. If you want to prepare beryllium hydride, then you have to use another method directly to prepare it. The rest of alkaline earth metals combined with hydrogen to form hydrides I have written here. Magnesium hydride, calcium hydride. So the hydrides of beryllium and magnesium are covalent due to smaller size. This is less ionic and more covalent. As we go down the group, this ionic behavior is going to be increased. Whereas the hydrides of other elements are going to be calcium hydride. So as we go down, ionic nature is going to be increased. So magnesium, beryllium is a pure covalent and also a normal condition, does not react with the hydrogen. Magnesium reacts but is much more covalent than calcium. This ionic nature increases as we go down the group. So this is the reaction of hydrogen to form hydrides. Reaction with alkalis. From these elements, beryllium is the only element that can react with the alkali. Beryllium is the only element. Beryllium plus sodium hydroxide to give a sodium berylate and evolve hydrogen gas. Sodium is the only element in this group. Beryllium is the only element in this group react with the alkali sodium hydroxide to form the berylate and evolve hydrogen gas. Other elements do not react with. Other elements, alkaline earth metals, do not react with alkalis. This is clear. Now, behavior of oxides and hydroxides. I told you oxides and hydroxides of beryllium are amphoteric. This beryllium oxide can react with the acid as well as react with the base. So beryllium oxide reacts with sulfuric acid to give a beryllium sulfate and water. So this chemical reaction with the sulfuric acid. So it can react with also base to give a sodium berylate and also water. But magnesium oxide, calcium oxide, strontium oxide, barium oxide, they are basic in nature. Oxides of other magnesium, calcium, strontium, they are basic in nature. Okay. Carbides. Beryllium carbide, calcium carbide, they belong to same group. Beryllium and calcium belong to same group. So when they are going to react with water, so this beryllium carbide react with water to form a beryllium hydroxide and formation of methane gas. To form methane gas, this is a methane gas. When calcium carbide react with water to give a calcium hydroxide and formation of acetylene gas, ethylene gas. This is acetylene gas. Ethyl triple covalent bond. This is ethylene. Acetylene gas and ethylene gas. So you can see the difference here. Behavior of the carbides with reaction with water is going to be different here. It forms methane, beryllium carbide form methane, but the calcium carbide form acetylene, and this is only your information. Organic chemistry, if you study organic chemistry, you done in the grade 10 organic chemistry. This is the ethylene gas, is the organic compound. Ethylene gas, generally called acetylene, is a very important gas which we use in the petrochemicals to prepare many organic compounds, and also it is used as a welding for welding and also removing metal from each other, which is called oxyacetylene flame, and this temperature is going to reach about 3000 degrees centigrade. It's very high. So for welding purpose, and we separate the metal from each other, this technique is used. So this acetylene is a very important compound, and accidentally it was prepared by the scientist. Accidentally. I'm not going to detail. He was actually doing the experiment for other purpose. So when the calcium carbide is going to be formed from his reaction, he at that time he didn't know what happened, what product is going to be formed. Many times he repeat this experiment. Then he put this product in the sink. Then there was water in the sink, the gas evolved. Then he did the experiment repeatedly. Then he discovered that acetylene gas prepared. This recipe you can see from the data also. Behavior of nitrides. Beryllium nitride is a volatile. Volatile means which is a liquid and evaporates at room temperature. It's called volatile liquid. While nitrides of other alkaline earth metals are non-volatile, they are not going to be evaporate at room temperature. Now, I told you students, I told you number of water of crystallization. I told you about this. Now in the water of crystallization, already I have written the electronic configuration. So this is the last electronic configuration, valence electronic configuration of alkaline earth metals. This P is empty. 3P is empty. 2s3p. 1s2, 2s2, 2p, 3s. For the beryllium, it is 2s, and for the is 2p. And for the magnesium, it is going to be 3. Then calcium go down the group, orbit is going to be increased. So this is the for beryllium. The salts of beryllium ion cannot have more than 4 water of crystallization. 4. Electronic configuration of beryllium is 1s2 K shell, 2s2 and 2p0. So only 4 electrons can be accommodated. Means we can put the 2 electrons. If we shift here, 1 will be here, 1 will be here. So that's why 4. There are 4 orbitals, unpaired electrons. So it can coordinate with the water, 4 water molecules. Coordination number. This explained as follows: each of beryllium ion has more. There are only 4 orbitals, namely 1 orbital can be accept lone pair electrons, donate oxygen atom to each of water molecules as this. So this is going to be formed like this. Like this one. 4. Unpaired electrons are 4, so they can make coordination with oxygen of water. 1 water molecule, 2nd water molecule, 3rd water molecule, 4th water molecule. So there are 4 water molecules. So that's why water of crystallization with the beryllium is 4. Now, on the other hand, alkaline earth metals like magnesium can extend their coordination number to 6 by using 3s and 3p orbitals also. 3s and 3p orbitals, and 2 belong to D3D, means 3s, 3p and 3d. This is the 3s and also 3p like this, and also 3d. Yes, 5. By this one. So they are going to be filled with this 1 in each to form a coordinate covalent bond. So more than 4, 1, 2, 3, 4, 5 like this one. So more than 4 electrons can accommodate to form coordinate with the water. So this we can discuss in next chapter, inshallah, in the D block elements, complexes. So coordination number of 6 and using 3s, 3p and 3d electrons also belonging to their outermost shell. So these complexes are given. Already I told you beryllium ion is account of the smaller size and form a stable complex, beryllium trifluoride. Like this one. Beryllium trifluoride is going to be formed here, and beryllium difluoride, and also while other alkaline earth metals, very few complexes of compounds are there. That's why this is different. That beryllium can form complex frequently, but the other elements are not going to form complex frequently. So dear students, here we finish this topic, and there is a quick quiz. So go through this quick quiz and solve all the questions. This is given on the page number 37. If you see your book 37 page, there are many quick quizzes. This is assignment from myself. You have to solve also exercise questions related MCQ you have to solve. If not possible for you, if difficult, you can ask me. So inshallah, from the next topic, I'll start group 4 elements. I'll start group 4 elements. Thank you very much.